So this panel today is on the decentralized AI stack. So like training, inference, and fine tuning. So yeah, I guess like based on the projects that we have on the panel, I think we're probably gonna like tend more towards like compute and training, that sort of thing. But there are other layers in the stack as well. So I just wanted to give a quick definition of the decentralized AI stack from my point of view. And then I can ask everyone else if they agree with us and also where you see your projects fitting in that stack. So I think like I kind of split it into three broad categories. The first one is like infrastructure. So basically like storage and compute. There's also a broad category of data and then a broad category of like intelligence or like the app layer as well. So in the data layer, we also have stuff like indexing, like using Ceramic protocol, like data marketplaces, like kind of payments, access control, all that sort of stuff. I also have verification in there, although that could also be in the infrastructure category, I'm not sure. And then in the intelligence category, we have like fine tuning, inference, we have agent frameworks, we have like apps like AI assistants, maybe like orchestration, workflow orchestration and stuff like that. So first of all, maybe you can all tell me how you think of the decentralized AI stack and all of the different layers that make it up, and also where you see your projects placed in the stack.
Yeah, I can kick it off. So I guess I like that framing that you gave, Richard. I think we think about it obviously in a biased way about the kind of fundamental resources that sit underneath it. So I'd separate those out into probably three categories, maybe a fourth category that's kind of derivative. So you've got the compute that's required to train models, you've got the data that's required to put into the models, and then you've got the expert knowledge required to generate those models and kind of the structure, the architecture of them, etc. The fourth category I'd put in is kind of usage. It's a weird one, but I think it's quite important because realistically it is a kind of underpinning value to ML. It has no value if you have no usage, essentially. But it's kind of a bucket category that probably encompasses a load of yours. So it's a bit of a cheat, really. And then to explain where Gensyn fits, Gensyn is solving the compute problem specifically. So we're a decentralized compute protocol. We sit at the lowest kind of level possible, just on top of hardware. We connect up theoretically all of the hardware in the world that's capable of doing machine learning training and allow it to be used by anyone to train models at any point in time. And when I say training, I mean essentially distilling value and data into model parameters in some way. And that's distinct from inference that other people are doing and has completely different challenges. And we're laser focused. We only do compute. We think verifying that the work has actually been done correctly is the most important thing there. And the future we want to enable is essentially all of the compute in the world is just always available in this kind of liquid way at any point in time. If you need to distill value from data into model parameters, if it's a tiny shard of a model or maybe a whole model, it doesn't matter. You can just do a transaction with a device and you can have that work be performed, and you're essentially paying for the ops themselves. On top of that, you can build tons of stuff. Around it, you can build tons of stuff. We have no interest in doing that. All we want to do is control that small communication portion where you're accessing the compute specifically. And like I said, like inference and other things like that have completely different problems to compute. So our goal is to have other people build those things, hopefully, and then integrate with them.
Cool. I think, Richard, I think we posted similar things about these three different layers of AI Web3 and stuff. I mean, we discussed this a lot in the past. Yeah, so basically, totally agree. I like the neat way to layer out the category of the competitors or collaborators in this area, like infra layer, as you mentioned, data or compute, right? So like, I think players in data area, like there are old players like Ocean Protocol or Alweave. There are also new ones trying to tackle into the new AI world, like using index for vector space, like RSS3 or move space, JC's there. So I think, there are many of those players, and compute, of course, Gensyn, everyone knows him. Akash, Ionet, everyone knows them. So those are the important fundamental layers of this. Because they are they are providing either data or compute to the models that's eventually going to be trained or fine-tuned. So that, as you said, lead to the second layer about the intelligence, intelligence layer. Yeah, I think that's a better name. I call it middle layer, but yeah, intelligence sounds intelligent. Yeah, so I should do that. So yeah, yeah. So we as Flock, we fit into this intelligence layer. The name of the Flock is actually originated from a research paper that we published before about federated learning and blockchain. So FLOCK, Flock. It's a pun. I like puns. I'm also a talk show comedian in London. If you want to attend my sessions, I'll let you know. The original idea is using federated learning that data can stay locally and computers go. We distribute local model to the local machines to do the training or fine tuning, right? Then because of the centralized control, now Google is doing it right now, like Apple is doing it to train your typing habits, but Google is controlling it, right? You don't know whether they are going to be able. So the reason we have blockchain is to have this decentralized consensus that we do not need a Google to do the middleman managing everything. We just form a consensus by all the trainers joining one training session. So we got our papers online, just search Flock, you'll see a lot of them on Google Scholar maybe. That's also why we met Richard back in 2022, New Rips, the session, the first ever session about blockchain and AI, So and then the second layer, as you mentioned, application layer. There's many. So in the beginning of this hype, I would say there are many hype projects, which is just doing some related work, but not necessarily an AI plus crypto project, like NFT and generative arts and just an NFT license or some IP co-sharing type of things. But those are important. But just nowadays we see some more interesting projects like they stay in application layer, but still create a lot of value to the whole ecosystem. Like my friends, MyShow, doing similar things. Yeah, and they create those agents that you can just pump through. You can choose different models or work with them with different models. Yeah, so that's generally my categorization as well. And I see lots of good companies, very, very deep companies coming to these three sectors. And yeah, that's quite exciting.
I think there's been a lot of good categories already covered, so I won't probably add any more, but just wanted to give a quick overview on where Ritual fits in. So Ritual fits pretty squarely into, Ritual is a coprocessor for AI, and we pretty much squarely fit into the inference layer. So we work a lot on how do you add, for example, new applications or protocols and add AI easily into your stack. So that's mostly what we focus on. The one thing I think is also an interesting kind of bucket that may have already been mentioned is the idea that in Web 2, for example, a lot of monetization for models, data contribution, for example, incentives haven't really been figured out. And I think that bucket of things where crypto can be the payment rail for a lot of these services could be also a pretty interesting kind of direction. So for example, Hugging Face has been experimenting with a lot of, for example, monetization, but that hasn't been kind of figured out. Neither has been, for example, proof marketplaces.
I think broadly speaking, the categories I can align with that categorization, I think. But what Akash does is, Akash is the world's first super cloud. It's decentralized. A super cloud is a layer that sits on private, public, hybrid, no matter what kind of computer, essentially a cloud-capable computer, and gives a robust and a familiar interface to schedule workloads on this computer, right? Just like any good cloud, it has a very incredible orchestration layer and a marketplace to trade compute cycles. Right now, Akash is the only place to get on-demand H100s or A100s, which is, honestly the spice of life, right? If you think about GPUs are going to be probably the most important chipsets for humanity for the next, for long future. So Akash is very common trade spice. Spice must flow.
I totally agree with your conceptualization of decentralized, the different kind of buckets that can fall into, and the way that Manifold plays into these buckets is by developing verification systems. And we operate, for example, on Bittensor, on subnet 4. So what we develop is what we're focusing on is being able to like grow the compute. So, on the infrastructure side, we don't mind, like, for example, I use Akash all the time for subtensor nodes. And you can use that. You could use any other kind of infrastructure. That's not what we define as the subnet operator or the verifier. What we work on is we say, okay, hey, we define a custom consensus, and then we are able to grow the compute out of that to power apps, because I think a lot of the value accrual is going to happen on the app layer here. And if you look at some of the ways that I think a lot of people are taking this approach, it's like the UX of a user paying per query or per message is probably not going to be good unless it's prepaid. Like, oh, I deposit 100 credits and then it goes through. I think something like that works. But with Bittensor, it's much more of like the tau token is like a Higgs boson. Higgs boson, the God particle, describes mass. So the more mass or the more Higgs bosons you have, the more mass you have. And the same way with Bittensor. So on subnet 4, we're able to leverage that subnet to be able to power Sybil.com, which is we're working on a decentralized search engine. Right now we're using subnet 4 to develop to power the language model Inference, but we're also looking to implement or extend Bittensor's like package library to other languages like Go and TypeScript, so that we can do even more challenging problems like indexing. So we'd be able to grow our own index of the internet without ever having to, like, all we had to do is define the verification mechanism and the incentive, and it just grows. So this is where Manifold kind of plays in.
Super interesting. Yeah, I think most of the projects here are kind of in like the compute layer or the distributed intelligence layer. I'd love to hear more about how you all think those two fit together. I think we've got a bunch of interesting examples, like Gensyn, for example. You do the compute layer, but you've also been interested in federated learning and stuff. So you're kind of like bundling this intelligence layer with this compute layer. Bittensor tends to focus on the intelligence layer and less so on the compute layer. Yeah, I'd love to hear more about how you think these two fit together. Like, I guess you said already you're using Akash, the compute layer. So how are we going to see a lot of different projects that kind of work on the layers independently? Are we going to see projects that are kind of like bundling them together? How do you see that playing out?
Yeah, I think ultimately they're completely linked, and Gensyn has a very specific vision of the future that we will enable certain primitives for that to happen, but a lot of other things need to happen for us to get there. But that vision that we have is essentially that the internet right now is this sort of rich network of text. We all kind of share human knowledge via text that's stored on all of our devices, and we can query that text, but we're doing it via kind of language. The future that we see is that will be replaced with embedding spaces, essentially. It'll be replaced with models and pieces of models. And those pieces of models will be over all of our devices. And essentially, it's the new internet. We call it the machine intelligence revolution, but that's a bit like kind of out there, but essentially it's this replacement of what we currently have with text with just deeper information. It's essentially compression of what we've got. And for that once that happens, we can then interact with it in completely different ways. And that requires all of these new ML techniques that we talk about. It requires federated learning across all of these nodes. It requires coordinated decentralized training that's efficient over nodes that have heterogeneous latency and bandwidth. It requires a completely different way of thinking about the architecture of models, and some of the ways that Bittensor is incentivizing the creation of these models will be absolutely essential in the future. So all of the, I think, techniques that ML and crypto has been developing over the past few years all need to come together to enable that vision of the future. And then with Gensyn, we see ourselves very simply as just the compute portion. We think for that to exist, for it to be as free and kind of instantly accessible as we need it to be, the compute layer just needs to happen. It needs to be instantaneous. You need to be able to trigger that value transfer of value in data into models instantaneously with no humans involved. Models need to be able to trigger that themselves. And what we'll get then is this ecosystem of models on all of our devices behind all of the technology that we interact with at all times. But like I said, that requires all of these techniques that have sort of been developing in silos. Like federated learning kind of came about for data privacy reasons, but actually it's really applicable to other distributed training problems. So it's generally a kind of interesting confluence of a load of techniques that have existed in multiple different disciplines for a while, all converging together. And yeah, like I said, we see ourselves as a primitive underneath that that's essential to enable that. There's plenty of other primitives and there's plenty of things to build on top of it.
Definitely. I'm a very pragmatic person. So taking it back to like, why would we build like a decentralized network in the first place? From a pragmatic perspective, I think that it's to make things cheaper, to make things more secure, and to make things faster, right? And if you don't hit on all three of these, then you're not going to be able to defeat these sort of centralized pools or laurels. And a good example of this is like Napster and Spotify, right? Napster was free, which was great. Music had never been free up to that point, except on the radio. You didn't get to pick what you listened to. You could find every song you wanted right there at a click of a button. But it wasn't secure. Sometimes I'm seeding viruses to other people, right? And then you're getting in trouble. So Spotify came along and solved this through a centralized solution, right? A very pragmatic solution, and that won. I think that if we're looking at, fast forward to 2009 with Bitcoin, we solved the security aspect of being able to run these decentralized networks, right? And I think one of the best things that Bittensor really delivers on, right, from a pragmatic perspective, is the speed. So as the subnet owner, I have to define the consensus mechanism or the verification mechanism. So, how are people going to be incentivized? I have to look out and make that actual process secure as the subnet operator. But what's great is that I can, while I love Greg, Greg's great, but the reason why I like using Akash is because it's cheap, right? And so a decentralized network is providing on all of these three things. And so I can use that on my subnet to be able to build a really great application that people can use. I think that if we're going to get to 10 million, 100 million users on some of these applications, right, the throughput needs to be like Web 2 or greater speeds. And so this is where I think that these kind of, where do I think the interop here is you could use Akash, you could go and buy your own GPUs. It's not really up to me as the subnet owner to define exactly what type of compute you're using, unless I'm specifying that. Like on subnet 4, I do specify I need a particular type of GPU, right? But it's not enforced, right? It's completely free, up to you to do what you want to do. And so this allows me as the subnet operator to build a really great application where now we're able to do 20,000 queries a day, just organically, and we're able to improve on the product. And then it took someone 3 queries to find the answer they were looking for. Like I can optimize for that solution without ever having to do like a chain upgrade or something along those lines, right?
So I'm a big believer in open source software. Why? Because with closed source, you can go fast, but with open, you can go far. Open systems building upon each other is how we can go fast, right? If you look at Unix is a beautiful operating system. The well-defined text inputs and outputs for each command makes Unix programs extremely interoperable. And if where I see parallels with Bittensor and Unix is Bittensor adds this incentive layer on top of this, clean inputs and outputs for each sort of like command. If you think about subnets as different commands, to simplify it. And Akash is essentially another command is part of the Bittensor, operating system, right? But the as important as decentralized networks exist, the interoperability between these networks has to be simple enough and robust enough to build truly decentralized, truly mass scale systems, right? And that's why we believe in doing one thing, doing really well. Akash is a super cloud. What supercloud does, not too many people know, Akash is one of the largest IP address marketplace I'm not going to give you ideas what you can do with the IP address marketplace here, but that's one of the key aspects. Akash is used by healthcare companies to store HIPAA compliant data, right? So Akash is used by NSA for they're doing a project inside the Department of Defense to do whatever they do. They don't talk about it, but Akash is so robust and so simple. It is composable, part of a larger protocol, and that's going to be a key driver for Akash. And more things we do as a protocol means bigger attack surface. Bigger attack surface means more brittle. So the protocol has to be very simple. And I think protocols or systems that build upon this open, simple, permissionless, censorship resistance as a primitive is key, because when you build on Akash, the guarantee you get is you own it. No one's going to stop you, and you can change it, right? You can make a proposal. Don't complain. Just make a proposal or send a pull request, right? And that's the beauty of this open system. That gives me a lot of confidence, and I believe that's how the world should work, with people cooperating with other people and be able to remove the friction for coordination across the globe.
I'll just add one thing, which is that I think open source, open weights, and spectrum of openness and models come from necessity. There are currently a couple of different companies with closed source models or closed source weights, but the way of, for example, iterating on a lot of model inference and new fine-tuned models need those weights or need open source models to be able to have community contributions. And so I think a lot of how we think about having a lot of people run nodes so everyone can access inference cheaply and quickly for all sorts of models to fit their needs is going to be much faster than a centralized company that kind of doesn't let users tune the models to what they need and what they define to be their values.
Yeah, well, since we don't do compute, so not too much comments here, but I always just want to ask Jensen, when can we use your product? Right.
When the tech is ready is the answer. We have a really specific view that we need to get these primitives right. I think there's a bit of a rush at the moment to build networks that ostensibly solve some of the machine learning problems that we have right now. But I think what we've learned, we've been running Gensyn for 4 years now. We've been doing a lot of research into solving these primitive problems. And I think it's absolutely crucial that for us specifically, we solve the verification problem. If you don't actually know that the work that you've pushed to another device has been done properly, it will get exploited. People will come along and they'll extract value from that system because there'll be ways for them to extract value. And we've thought about plenty of different ways to incentivize doing that compute properly. And the conclusion we came to was you have to incentivize the exact piece of work that you're actually wanting to have done. You can't use a proxy incentive to make that happen, because people will pursue proxy incentives and they'll extract value from the system. Your outflows will be greater than your inflows and the whole thing will collapse. So the unfortunate answer is, yeah, as soon as the tech works and we're happy with it, people can use it. But come and talk to us if you do want to use it. We will be moving to DevNet and testing things with people. We won't kind of put a token live or launch a mainnet anytime soon, but we will happily give people access and let them break things and give us feedback.
Okay, we will try to break it.
Please.
Okay, great. So yeah, I'm so glad that Greg mentioned Linux. I was going to touch on like verticalized solutions versus like horizontal. I know like in the the history of the computer, there are kind of different generations, right? There's like first generation was the mainframe, then the mini computer, personal computer, and laptop. For the first two generations, I think it was like mostly verticalized solutions that won, right? But then for some reason, in the third generation with the personal computer, we saw like horizontal, where a lot of different pieces come together to build this platform, right? And there's other examples in operating systems. For example, like Mac OS is this kind of like verticalized solution. Linux is often given as an example of this like horizontal solution. I think a lot of the people on this panel are building pieces of the puzzle that could potentially go towards something like a personal computer or something like a Linux. And my question is around like what sort of coordination needs to happen for that to happen, right? Like, do we need like a Linux foundation to like figure out how to put the different pieces of the stack together? Does it just kind of happen organically over time? How do you see that playing out? Or maybe it's verticalized solutions that you want to build, right? Who knows?
Yeah, so I definitely think that when it comes to, or just touching on why Linux became so popular, the two main things that really matter when getting these sorts of things out into the world and having people use them is cost and distribution, right? Software is really great on both of these because it is marginal to distribute one more piece of software, right? And so, or to sell it at least, right? And so the way that I see at least the amalgamation of different protocols and projects and ideas, I think it's a little too early. It's early innings to say which idea is going to be the definitive winner. And as a result of that, I think that what we're going to see is like a very organic, like city planning codes, like how it's like you can't build, like in Houston, Texas, you can have an amusement park right next to a single family home, right? Because there's no zoning laws, right? I think it'll end up like that, where you'll have this amazing amusement park and Ferris wheel right here, and then someone's house like right next to it. And so because there isn't that rigidness, if that makes sense, right? So
fortunately, digital space is a lot easier to explore than a physical space, so we won't have the traffic problems Houston has. But most certainly, like, what excites me about these open systems is the diversity of open governance networks, right? Like, when it comes to Akash, Akash has about 480 contributors, and 20 of them work for Overclock Labs, which I'm the CEO of. So 90% of the contributors have no direct control or say. And every product meeting happens in the public, and they're posted on chain. It's summarized, and go to GitHub/Akash, you'll see every meeting is summarized and known to the world and recorded for perpetuity, right? So that's important because, and there's a public goods fund, you can apply for grants, and Akash website is maintained by a team of developers in India. I haven't met them. Every aspect of Akash is managed by someone else, right? In terms of the non off-chain assets, 100 validators. We don't run a single node. Hundreds of providers now. So it's a very open, decentralized system that has its own way of self-sustenance. And there was also a new article that came on Silver Lining that talked about open source sustainability and how crypto is actually a way to solve open source sustainability. Even companies like Docker couldn't exist because, well, they were following the old model. The old model doesn't work anymore, right? Docker went out of business. They sold to Nutanix for peanuts. And Kubernetes is having a crisis with their contributors. They have a contributor churn because there's no way for people to work on something full-time and get paid for it as an engineer without boundaries, without restrictions, right? And there's talent everywhere, it's global. And how do you get to the talent? What kind of incentives are you creating? How do you define a governance mechanism that actually works? We don't like to call ourselves a DAO because DAO has really bad juju, but effectively we learned a lot from the grandfathers that came from Linux Foundation and Kubernetes Foundation. We took those governance structures and implemented them. Now, Bittensor has a different governance structure, right? But we can still work together as open systems with open governance with open governance. And that's the beauty of what we're doing. Like Rob said, it's too early to make the call as to is it going to be a foundation that's going to lead the whole thing. I don't think so. I'm not a big believer in centralized plan models. I believe in more organic free market. So as a free market fundamentalist, I believe it could be organic. If we're going to build a digital Houston, that's going to be way better than physical Houston.
Preach.
Also from Texas, so it doesn't.
I think at Ritual, a lot of our approach is fairly horizontal and open, and I think compatible with other systems that are also open. So, for example, we opened our Discord about 2 days ago, and within 48 hours, the first application was built from someone with basically was permissionless. They built a haiku generating app that was using a callback function with Ritual's stack without any help from the team. And so I think a lot of the permissionlessness of a large range of ML workflows for our stack at least is pretty modular and kind of choose your own adventure in terms of the horizontal design. So I think I pretty much agreed with the other two takes here, which is that I think a lot of the open systems, given the large range of kind of applications and buckets right now in AI is fit for an open system.
Yeah, totally agree. That's the reason why we do Web3, and that's that's exactly the mission of decentralized everything, right? So we don't get to see a big monopoly building from, let's say, which was originally just a book selling website, and then they started to do compute, and then started to do the machine learning layer over it. Oh, that's called AWS. So yeah. So in our world, I think the beauty of it is we have these protocols. For example, Flock. We have our own training frameworks, and then if you like compute from Gensyn, you choose Gensyn. If you like compute from Akash, you do Akash. Or maybe one day, yes, we will grow a bit like vertically, but then users got their options to choose whichever compute they want to use and whichever data storage they want to use. They want to either store their data on their own computer, right, or use decentralized way to store them. And then they choose different models and different applications. Like on Flock platform, what we are trying to vision in the future is that planners, they can put up different tasks on Flock. Like I want to fine-tune a model with my fellow community, which is a very niche interest. Maybe some centralized model providers will never care about us, but I would like to do something like that. So yeah, I put up tasks and then people join together. They just fine-tune a model. But in terms of tech stacks, they can use whatever they can see in this whole market. So that's what I love about Web3, right?
Okay, awesome. Do you want to go?
Yeah, very briefly, I was just going to say, I think all the companies here are a good example of the fact that we now have a new business model that allows you to build a horizontally scaled business protocol, whatever you want to call it, that kind of new terms that are available to us that just previously didn't exist. Like if a company wanted to scale, it pretty much had to capture more of the stack vertically. So it had to move into different areas. Whereas now we've got this much more collaborative ecosystem where just general usage of the technologies is the thing that most protocols are trying to maximize. So if usage increases, we all benefit. And so you can create this horizontal layer where you're just doing one thing very, very well. But as long as other people are doing all of the other things, your piece of the pie grows, essentially. That protocol increases. And I think that's really good. It's a much more natural growth mechanism than trying to have companies capture the entire stack from each other. And I think it's down to the competition that you get in Web3 and crypto, where it's very easy to fork a protocol and make a new version of it, which means that each protocol is driven to do one thing really, really well. If it tries to branch out and do other things, it's likely that somebody will come along, do one of those portions even better, and just carve it back out again. So it forces businesses to essentially stay horizontal, work together to grow the entire pie, rather than becoming kind of selfish and trying to capture the entire market vertically. Because what happens then is that it's worse for the consumer, because the consumer doesn't get the benefits of competition and all the advantages that come from driving optimization in each of those areas.
Really interesting, yeah. That's all the cooperative stuff. I was going to push a little bit on competitive because we always get asked by VCs, where's the defensibility? Where's the value going to accrue, right? I know you mentioned already, you think the value is going to accrue to the app layer, right? I'm sure some people here would beg to differ and say it's going to accrue to the compute layer. So I'd love to hear what you all think, or maybe it's going to accrue to all layers equally. Who does?
No, app layer absolutely captures the most value. It's ridiculous to say that any other layer does, right? But infrastructure layer is not about capturing more value. It's about providing a decentralized network. The big difference, I think, we got to come out of the mindset from a defensibility and all this crazy whatever VC talk really comes down to, does the product work or not? $2 H100 is beat that, right? Right, product works. So it's going to capture the value it's supposed to capture, but I think app layer absolutely captures. I mean, Facebook is third largest company or fourth largest company in the world, but NVIDIA is kind of getting there. But they are not they provide the chips, right? So, but obviously a company that's going to use NVIDIA is going to be a lot more valuable than NVIDIA, right? For sure.
Yeah, definitely. And to say that AWS is in an amazing business would be, I think it would be nonsensical, right? Because it's so large and runs large portions of the bandwidth that happens on the internet, aka like Netflix, right? And so the infrastructure layer is definitely a great business, right? And a great protocol. But if we're I think that on these outcomes that we see, I think that you don't see as much churn on infrastructure. You put the cable in the ground, it's very hard to get it out of the ground again, right? And so the infrastructure players, I think, will very much harden as a result of that, right? However, the app layer, there is a lot more value to be made, but there is also a lot more churn. And so because there is more churn there, I would say that it'll trickle all the way up to the app, but there'll always be apps bubbling up. That makes sense.
Right, and also the analogy with like the gold rush, right? Do the pickaxes made money than the gold diggers, or the gold miners, right? Yes, few gold miners got very wealthy, but the pickaxes got very wealthy too. So I think this here with decentralized systems, we have such clearly defined places for each stack. At least that's where the horizontal scaling comes, right? So I'm excited about that. I think it's shared prosperity across the board. I think real people that value are the people that use the system. That's what's most important in decentralized systems. It's not protocols, it's the people that use this use these systems benefit, not the shareholders of shady corporations.
I think those like attribution flows of value are crucial. Like once you get those like horizontal layers, rather than thinking about value capture at those layers, like how can we just like take more of the value that's flowing here to a centralized company? Actually, what we've got is this competitive ecosystem where the value goes to where it should be attributed to. Like within the compute layer itself, the value goes down to the owner of the compute. Within the data layer, the value goes down to the originator of the data. It isn't captured by this intermediary, which is how it's currently working in the centralized world. I think like Greg said, there'll still be value capture at the application layer. Like people will still build centralized businesses on top of decentralized technology, but because you've got the decentralized technology underneath that isn't doing value capture, it means we even get a richer competitive ecosystem at the application layer. So it's much easier for a competing application to come along and build something that will disrupt an existing one. So essentially the value, in my opinion, heads back to the consumer. We just get cheaper everything because we have a much more competitive market that isn't capturable by a cloud giant for a reason that isn't intrinsic to their business. It's some kind of rent-seeking behavior, some kind of monopolistic practice. They've used some mechanism in the real world to push out competition and essentially become lazy. And as consumers, that's why we end up with just shit experiences. Like we're using a service, but we're like, there could be a better version of this. I could build a better version of this, but for whatever reason, I can't get the GPUs or I can't get the data because it's like behind paywalls, or I have to recruit it as Google before I could do it or something. So I think that, to me, again, the real value goes back to the actual users themselves. They just get better services for cheaper, but you'll always have that kind of capture at the application layer, as Greg said. It'd just be more competitive and less easy for those businesses.
Yeah. So as everyone just said, the value or the defense where these three layers all rely on to, I think one very important thing is the community, right? This whole decentralized community and the tech stacks that we're building, every one of us are building, are trying to give them kind of like the ownership of the thing that they're creating. Either it's a model they're co-creating together, or the data that actually they own. They are not giving out to any third party. They're not giving out to any centralized model. And that model they build together is what they build together. It's not that OpenAI tuned for me already. I'm just calling the API, right? So I think this is super important and a very much the defense for all of our companies, that you have your own community. That community believes that this co-created or co-trained models, apps, or computes, that's they have their value distributed to them. They own it. The feeling of ownership, I think that's so important.
I think the value accrual probably looks similar to what people have mentioned before, which is that a lot of the killer use cases came about for OpenAI when ChatGPT came, even though the model itself was already there. So I think in Web3 as well, there will be lots of shots taken at some of the killer use cases that people will end up having value accrual to the users that will end up benefiting a lot of the app layer, which is pretty much the most important thing. But as time goes on, I think the picks and shovels definitely have to be there to go along, just as NVIDIA was for a lot of that to happen.
Okay, great. We're just about up on time. I think that's a pretty nice vision for the decentralized AI space to finish on. One that is cooperative, but also highly competitive, doesn't have lock-in, and these sorts of undesirable effects. So if we can do that, I think maybe we have a good chance of going head-to-head with centralized AI. But yeah, I'd love to, I think we have a few minutes for questions, right? If we want to open up. Does anyone have any questions?
So Robert brought up like a lot of things around coordination, and so where does there's kind of like a gradient, and where does the compute start turning into like the applications and start turning into like the social, start having social effects on it? Like, so like where do you see this impacting our lives, and how does it flow through that? Like Jensen's working on bare metal, almost on bare metal, and then working the way up. So like how does it affect society? How is it going to affect society, basically?
Yeah. So I think the most poignant way it'll affect society is through cost. So a great example is with what we're doing on Subnet 4. Another great example is Akash. You can get really good priced H100s or A100s on Akash, but you cannot, if I wanted to go get it on Paperspace, I'm going to be paying like $4 an hour or something like that, right? Whereas I can get it for like, I think around $2. $2
for H100.
Yeah.
79 cents for A100.
I mean, those prices are amazing, right? And so how I think we start to see it go is it goes to Akash, right? A developer goes to Akash, right? And says, or goes to Bittensor, either one, right? Maybe they're just going to run it straight on Akash and then serve it through through their endpoint on Akash to their website, right? To their application. I think that's a way it happens. I think another way is like, what we would do on Subnet 4 is we would incentivize people to run A100s on our subnet and run a particular model that we can verify that they're actually running that. And then we're able to serve that on Sybil.com where people can use those queries for free. And we don't have to bombard you with advertisements that might not be relevant, right? So all of these sorts of I think we can even go further and further and further up, right? And it doesn't have to necessarily be Bittensor, and doesn't have to necessarily be Akash, but the ways that I think it trickles out into the world is through cost.
And like Subnet 27, your internet is running, getting Akash in the backend, right? So you're technically using Bittensor, but at the same time you want GPUs, you get the 79 cents A100s directly through Bittensor through Subnet 27. That's how interoperability I envision, and I think Bittensor is phenomenal for delivering that vision.
I think there's just a couple of other things additional to price. There's scale and access that I think will really unlock new use cases. So access is kind of derivative of price, basically. Like, can people currently get the GPUs? So can you get them at a certain price? Sure, but can you actually get them full stop? And there's a load of people in the world who would build incredible applications if they could get access to GPUs. And they're currently blocked for like the price reasons, but also just competitive reasons. Like AWS will pick the players that it thinks are going to be successful in the future and give them GPUs because they want to get more revenue in the future from them. What we need is a completely free market over the top of that, where there isn't a player sitting on that market and being essentially the kingmaker. It's just if somebody's willing to pay the price, they can get those devices. And then the scale piece, like we've got applications now where there's things that people could build that would use way more devices than are currently available from something like AWS, but they just can't do it. They can't get access to those devices, and they're not connected up in a way that allows these people to build these applications. So if you've got like federated learning, like Flock is doing, that allows people to build applications that could never have existed before. And I think that's what's really exciting to us, because it enables like a completely unlimited future. It takes away that ceiling that we currently have, where people can envision these new applications that use 100 GPUs in a data center. Sure, some of those are exciting, but what about the ones that use 1 billion devices at the same time? Those are the really exciting ones, and they can't exist without the infrastructure that basically all of us are building.
So I guess this could be a question for any of you, but in addition to the comparisons you brought up, another vector I think of making a decentralized and open source AI really valuable to the consumer is providing them with models that are just as high quality as centralized AI, if not better. So what do you see decentralized AI doing into the future in order to provide that to the consumer, especially with open source models compared to OpenAI, Anthropic, and so on and so forth?
I think it's letting people build those models. Because right now there's tons of smart people in the open source world that could build a model like GPT-4, for example, but they don't have some of the core resources required to build it. Like I was in this position, is one of the big reasons behind Gensyn. When I was a PhD student, I could only get access to 4 or 8 GPUs that I had under my desk in a workstation that I'd built myself. And I was competing with Google on the research, who had 3,000 GPUs that they'd run in a data center for weeks at a time. But I had the proposals for new mechanisms for optimizing the structure of neural networks that would be completely different, but I just couldn't run them. There was no way of me doing it. So if we can unlock the resources for the open source world can build these models, and it can be funded as well. Like I think Greg mentioned, or the other people have mentioned, like the public goods funding around networks like Gensyn, networks like Bittensor, etc. Like those flows can go into building things like GPT-4 and beyond. But currently, there's nowhere for them to go. Like we have to collect value within altruistic organizations who will then claim that they're going to go and build this for altruistic reasons. But within the crypto ecosystem, we can do that purely transparently in the open. We can say, here's a wallet address. If you're interested in the future of open source models, just send some value to this wallet address, and then we can have a group of open source developers who can then use that to build a completely new model. And I think right now the mechanisms for doing that can get captured too easily and are just too hard to use. So if we have these new infrastructures, they make them much easier to use, much easier to do, and we'll build new models that are on the forefront, and they'll be open to everyone.
I would totally agree with this. And then the 3 bottlenecks I think that are preventing currently open source models from obviously being as good as closed source models are architecture, data, and compute. And I think access to all of these that are being worked on across the panel will help us get there. So an example here is, for example, a lot of the ways people contribute to better fine-tuned models is through open source or open weight models. So for example, if you go into Stability's Discord and you see developers actively contributing their version of, for example, a TV show specialized model versus other types of models, a lot of that usage and inference comes from open models. And so for Ritual, I think a lot of the feedback from people building applications and the data that is contributed through use cases goes back into developing models and people who can access a lot of data that they could use to build better models for open source.
Yeah, just adding one more thing to this answer. Centralized training, the model that's being centrally trained, that's definitely better than, well, of course, than the decentralized training, of course, at this stage, right? But then there's one thing that's very, very important, that for open models, we can always fine tune them, right? The base models, they are already good enough. And then we look into one specific business use cases. We don't have to always have a very strong AGI for every single task. We just need a model that works in that specific task. So that's one of the things that I think the opportunity comes for decentralized society, and also data. So open data now is being like completely exhausted by those centralized model trainers, of course. But then I think the human being, the dignity of human being is the last mile of our private data. That's the last mile, right? That's not being collected by, I don't know, those big players, right? So that's where the power will be unleashed. That's why we do Flock, and so to ensure your privacy, but then you can still do something with your private data. That's something big players wouldn't get easily.
Getting access to compute, like Eva and Ben mentioned, is certainly one of the biggest reasons why small players like us really would rely on you guys to, like, I guess, give us a play field so that we can do the things that we do, right? It has to be affordable. It has to be a fairly good amount, right? So my question is on how do you guys tackle the challenge of compute on your side, and what is your vision and your strategy going forward to get access to a good amount of compute to support your community?
Incentives. One thing we're good at crypto, incentives. We're very good at it. Incentive design is hard, but it's achievable. So, I mean, before you do, then you have a series of experiments that we're doing. Fairly large, 7-figure per month experiments. Crypto is good at that. And it's a feature, not a bug. It's really no other way. I mean, what can you do to attract more people to provide? Because the high demand, high density GPUs are very, very hard to come by, right? It's really, getting an H100 cluster going, or HGX cluster, which is great for training, it's very hard. Very few people have them, and they're all looking to maximize the profit. So it's a free market, and you have to figure out how to be flexible as a protocol to be able to acquire that compute. And second of all, through gamification, right? I mean, for 4090s and 3090s, that's essentially a different type of incentive distribution curve, right? Whereas H100's HGX has a different type of incentive distribution curve. So just being very sort of like market driven in terms of and being practical in terms of what kind of incentives and how the delivery of those incentives should occur is a challenge, and the ones that get it right. Also, the second thing is how do you keep the user? How do you keep the churn, right? Like, what is the come for the GPUs and what do you stay for? And that's also important. I mean, a lot of that is user experience, a lot of that is, value alignment in terms of permissionlessness and open source. A lot of that is the kind of distribution you have built on top of the supply. And if you don't nail that and you unlock the scale prior to nailing the demand, it's going to be hard. And for us, proof is in the pudding, right? We have 3x amount of daily average workloads from last quarter. Right now, about 2,000 active leases. That means 2,000 different applications running at the same time, right? So that's causes stickiness of the application. It's a lot of experimentation going to happen over the next. Maybe we got till 2026 before the supply chain bullshit goes away. So we got 2 years. So whoever has the biggest war chest is going to win. That's the reality.
I think you just build good tech, basically. You change the business model for people who own those devices. Right now, if you do buy GPUs and you want to speculate on essentially the CapEx to OpEx conversion of a GPU, it's actually really annoying and difficult to do that. So you can go and buy 1,000 H100s and stick them in a data center. And I think it is hard, but I think it's possibly overblown how difficult it is to get access to those GPUs. You can buy them if you've got the right connections, and people do buy them, and then they put them in a data center, and then they say, okay, I'm going to go out and earn money on these GPUs. How do I do it? And I have to go to AI companies, and I have to sell them the GPUs for a certain period of time, and then I have to have infrastructure. I have to have a sales team. I have to have business development people. I have to have all of these things around me as a business in order to do that. And I think what we're all building basically is the tech to just improve those businesses. It replaces all of those aspects with technology and allows them to, instead of having all of those teams and building all of that infrastructure themselves, just run some software and start earning a yield on that device. And I think ultimately what will kind of win, the network that will connect up the most devices, will be the one that just does that the best. We're in a period now where incentives are kind of important because lots of people are doing them and lots of people are giving an inflated yield on top of the devices in order to capture that supply. That will work for a while, but ultimately what will work in the long term is just the tech that actually gives a consistent yield, and that'll be the tech that gives a consistent experience to the demand side. It's the tech that actually connects up supply of GPUs with people who want to use those GPUs and enables the thinnest margin transaction between the person who's doing ML work and the person who is computing the ML work itself. So the clearest value flow through will be the one that makes the best experience in the future and will be the one that collects up the most supply. But we will see GPUs and other devices move between networks as they're farming incentives, as we've seen in crypto in the past, but it'll be the next year or two while that happens until those networks run out of inflation. And then after that, it'll be real usage that drives the actual demand.
I think incentives are definitely one way to attract the right supply to your network. The other way you could kind of create more supply is by making it easy to run on consumer GPUs instead of specialized enterprise GPUs. So for example, running on 3090s or on your own local models, which Ritual actually supports. And one way you could do this is you can have inference optimization in how you decode and how you do inference that lets consumer hardware also participate and create a bigger network of supply that can be running these models as well.
Thank you very much.
Thank you.
Thank you.